Hello, and this is Coach Holmes, and today we're going to be talking about algebraic properties, but using algebraic properties to prove algebraic equations. Okay, so we've done these before. We talked about addition properties, subtraction property, multiplication, division. We talked about those at the beginning of the year. But what are the properties exactly, and how do we look at algebraically speaking? So, some of the properties are as such. I'm going to write it in blue. Okay? So, if, and by the way, I'm writing this in a conditional statement, which basically means I'm doing if-then statement. If A equals B, then A plus C equals B plus C. Okay? So basically what that's saying is that even if A and B equals to each other, the addition for both of them, whatever number that may be, is going to equal the same. As long as the number you're adding to both sides are the same. Okay? So this is just what it looks like algebraically speaking. We talked about this before, but this is what we're talking about algebraically. Subtraction is the same idea. If A equals B, we got to put then A minus C equals B minus C. Okay? So pretty much the same thing as the addition property, but the biggest difference is now we're subtracting C from both sides. Now, multiplication property says if A equals B, how do I write it down? Then A times C equals B times C. Okay? So it works out the same way with multiplication as well. Because whenever you multiply A and B to both sides, it has to be the same. And now division property, if A equals B, then A divided by C equals B divided by C. And again, same thing works for division. It all works the same way. Now, there's four other properties that we still have to talk about. And these are the stuff we talk about that are new. These are new properties. Okay? So, for substitution, if A equals B, then A can replace B. Okay? So just try to give you an example. Let's say you have, and I'm going to write it in green and I'll erase it eventually, I'll erase it later. So let's say you have that. What this tells me with substitution is that as long as x equals 3, I can replace this x with 3. Okay? So instead of saying 2 times x plus 7, I can say 2 times 3 plus 7. That's what the substitution property does for us. It allows us to replace values as long as they're equal to each other. Now, reflected property. Did not mean to do that. Reflected property says A equals A. That's it. That's all it says. As long, it's just like 1 equals 1, 2 equals 2, -5 equals -5. Whatever the value it is, it equals to itself. no matter what. So that's always going to be the case. Now, symmetric property says if A equals B, then B equals A. Okay? So basically it's just vice versa. It doesn't matter if it's 4 plus 1 equals 5 or 5 equals 4 plus 1. It both works out the same way. Or, and I can write this down as I want to write this down as well. It doesn't matter if it's x equals 5 or 5 equals x. They're both the same thing. So it doesn't matter if you flip-flop it one way or the other. Okay? And now transitive property, this is going to be interesting. If A equals B and B equals C, then A equals C. Okay? And just to kind of show you how it looks like, A equals B while B equals C. So, as long as they're equal to each other like this, A is going to equal to C. As long as since A equals to B, B equals to C, as long as B is equal to both, then A and C can equal to each other as well. That's basically what it's saying. Okay? Now, so let's look at this one example. And we're going to solve this, but here's the catch. We're going to use properties for our steps, okay? So one of the things we got to do is I got to subtract 2 from both sides. So I'm going to subtract 2 from both sides, so minus 2. Now, what property did we just use? Well, if you look at the operation, that's what it tells us. We're using subtraction property. So the first step we're doing is subtraction property. Okay? So we're using subtraction property. So then I'm going to get 3x equals 21 minus 4x. Okay? Now I gotta add 4x to both sides. But check this out. And in fact, let me actually do it in green so that way y'all can distinguish the difference. But check this out though. My operation is addition. So I'm doing addition property. Okay? So I add them all up. 3x plus 4x is 7x equals 21. And negative 4x plus 4x just cancels out. Now, I'm going to divide 7 to both sides. So that way I end up getting 21 divided by 7, which is 3. Now, if you think about the operation we just did division. So we're doing division property. Okay? So, and that's how, and then this very last step, x equals 3. That's just our reflective property. Did I spell that right? Yeah. Okay. So That's all we have to do. That's the process. So really what we're talking about here is being able to prove equations. You learn how to solve this equation. But to prove it and to show the steps is what we just learned today. So what we just learned is how to prove the process of solving an equation like this. Okay? So just be aware that what we just did is the process of proving algebraic equations. Thank you and have a good day.